China just replaced a human soldier with a robot. It carries a rifle and walks on 4 legs. The Chinese military aired the footage on national television for the world to see it.
The Chinese state broadcaster calls it the newest member of China's urban combat operation.
It is neither science fiction nor a defense project hidden behind classified doors. This is happening right now. Live military exercises, factories running 24-hour shifts, and fighting arenas where robots are being programmed to knock each other out. But the most unsettling part is not the robots themselves. It is the companies that built all of this. They did not exist 3 years ago. And one of those companies built a robot so capable that millions of people refused to believe it was real. Let's get into it. The CEO of a robotics company, suited up in protective gear, walked directly in front of his own robot and let it kick him. The first kick missed, but the second one connected with his torso and sent him off his feet and onto the ground. And it didn't stop there. Robot reset and stood there, completely stable, looking like nothing had happened at all. That man is Zhao Tongyang. He founded Engine AI in October 2023, and he did that because nobody believed his robot was real. When Engine AI released the original footage of the T-800, the internet had already made up its mind. Spinning kicks, barriers breaking, airborne strikes landing with a precision that looked too clean, too fluid, too cinematic to be mechanical. Millions of people called it fake.
China's Engine AI unveils the T-800. Powered by NVIDIA AI, it processes its environment in real time.
Engine AI released raw, behind-the-scenes footage to prove otherwise. The skeptics still didn't move, so Zhao Tongyang stopped arguing. He suited up and stood in front of it instead. Pre-orders for the T-800 opened at $25,000 shortly after, and first shipments are scheduled for mid-2026. But Engine AI didn't stop at building a combat-capable robot. On February 9th, they announced something that had never existed before in the robotics industry. The ultimate robot knockout legend, URKL, the world's first. Commercial humanoid robot free combat league. 16 teams from universities and robotics startups worldwide each received a free T-801 instruction. Build the most intelligent fighting algorithm you can and bring it to the ring. The prize is a 10-kilogram solid gold belt valued at $1.44 million US. But if you think the teams are showing up for the gold, you are missing the point. Engine AI open sourced the robot's code for the competition. Every algorithm developed, every recovery sequence trained, every striking pattern built feeds directly back into the next version of this machine. Think about what that means. 16 of the world's best robotics engineering teams voluntarily stress testing this hardware under the most extreme physical conditions ever designed for a humanoid robot. And every punch thrown, every fall recovered, every knockout avoided makes the next version faster, smarter, and harder to stop. If a robot can survive a full force strike from another 165-pound machine running at 14,000 watts of peak power, it can survive anything a factory floor or a disaster zone throws at it. The Combat League is not entertainment. It is the most aggressive development program ever designed for a combat robot, and China built it on purpose. While Engine AI was putting robots in a fighting ring, another Shenzhen company was doing something quieter, but arguably more significant. In November 2025, UB Tech Robotics completed what it described as the world's first mass delivery of industrial humanoid robots. Hundreds of its Walker S2 units shipped to active industrial facilities in a single batch. The target was 500 units delivered by end of year. By end of December, 1,000 Walker S2 units had already been produced at UB Tech's factory in Liuzhou. UB Tech says it was on track to meet every target it set. This is not a pilot program. This is not a controlled lab test. These are full-size humanoid robots deployed on live. Factory floors at BYD, Geely Auto, FAW Volkswagen, Dongfeng Luzhou Motor, Foxconn, and SF Express. BYD even established a dedicated embedded AI lab to co-develop humanoid technologies directly with UB Tech. Dongfeng Luzhou Motor is using Walker S2 units to install front axles and inspect fluid fills in mixed traffic environments alongside automated guided vehicles. Foxconn is deploying them for logistics and material handling and consumer electronics production that runs around the clock. The tasks these robots are performing are not simple. Quality inspection of door locks, headlights, and fluid levels. Assembly operations including installing trim parts, seat belts, and logos. Material handling involving lifting, moving, and sorting components. Evaluations at BYD showed a 120% increase in component sorting efficiency after deploying Walker S2 units. The Walker S2 stands 1.76 meters tall, weighs 95 kilograms, and has 52 degrees of freedom. It moves at 2 meters per second, lifts up to 15 kilograms, and is built from aerospace-grade materials, reinforced with composites to withstand constant movement across long shifts. Its hands have 11 degrees of freedom each, giving it the fine motor control needed to handle precision components that require grip sensitivity, not just brute force. But the specification that separates it from every other industrial humanoid on the market is its battery system. The Walker S2 houses two 48-volt battery modules in its torso. When power runs low, it autonomously navigates to a charging station, switches to single battery mode, and uses its own hands to remove the depleted module, place it in a charging slot, retrieve a fully charged module, and insert it. The entire process takes approximately 3 minutes. The robot never fully powers down during the swap. This solves the single biggest operational problem in industrial robotics, which is downtime. A robot that needs 4 hours of charging is a liability in a factory, running 3 shifts. A robot that swaps its own battery in 3 minutes and keeps going is a viable replacement for a human worker in terms of utilization. UB Tech accumulated over 800 million yuan in Walker Series orders in 2025 alone. The largest single order was 250 million yuan. A contract at a data collection center in Zhejiang came in at 159 million yuan. A project in Guangxi committed 126 million yuan. Mi Auto in Hubei pledged over 100 million yuan. Revenue in the first half of 2025 reached 621 million yuan, a 27.5% increase from the prior year. Humanoid robots went from 10% of UB Tech's total sales in 2024 to 30% in 2025. The company is expanding to 5,000 units annually by 2026 and 10,000 by 2027. And it is not just Chinese manufacturers paying attention. Airbus has acquired a Walker S2 to evaluate how a full-size humanoid behaves inside its aviation production facilities. Airbus is not choosing a nationality, it is choosing who can deliver now. While Tesla confirmed in its Q4 2025 earnings call that no Optimus robots are doing useful work yet, UB Tech had already shipped hundreds of humanoid robots to some of the largest manufacturers in the world and was fielding orders from European aerospace. But the factory floor is only one part of this story. In January 2026, on the first working day of the new year, China's People's Liberation Army officially kicked off its annual training exercises. What those exercises included was broadcast on state television and watched by military analysts around the world. Units of the 79th Group Army conducted live force small unit integration drills aimed at seizing a hostile position. Alongside human soldiers, they deployed quadruped robots and an integrated drone combat system, combining bomb-dropping drones, smoke-laying drones, and suicide FPV drones, operating as a coordinated tactical unit. But the January 2026 exercises were not the first time the world had seen this. During the China-Cambodia Golden Dragon 2024 joint military exercise, CCTV broadcast footage of a robot dog with an automatic rifle mounted on its back, leading an infantry unit into a simulated building. In the same video, a 6-rotor aerial drone was shown, with an automatic rifle mounted underneath it, illustrating what state media described as China's variety of intelligent unmanned equipment. A soldier identified as Chen Wei spoke directly to the camera during that exercise. His words were unambiguous. He said, "The robot can serve as a new member in urban combat operations, replacing human members to conduct reconnaissance, identify the enemy, and strike the target." That is, a serving PLA soldier describing a robot as a combat replacement for a human being. Not a researcher, not a government spokesperson, a soldier in the field. In November 2025, CCTV footage showed quadruped robot wolves developed by the China South Industries Group Corporation sprinting across a beachhead ahead of human troops during a simulated amphibious assault.
If they're able to clear some kind of path, the human beings, foot soldiers following behind, know that it is then safe.
The 70-kilogram robots breached obstacles and cleared a path for follow-on forces. Some were configured for attack, others carried ammunition, medical kits, and provided reconnaissance and fire support. State media reported the drills cut the time from detection to destruction of a target to under 10 seconds. The robot wolves navigate various terrains, conduct precision strikes from up to 100 meters away, and operate in coordinated packs, with some units acting as scouts, others as shooters, and others as supply carriers. According to the Global Times, new equipment is not typically brought into joint exercises with foreign countries unless it has reached a certain level of technical maturity. The Golden Dragon exercise was a multinational drill involving Cambodia. The fact that armed robot dogs appeared in it was not an accident, it was a signal. What makes China's approach different from every other country experimenting with military robots is not the hardware, it is the doctrine being built around it. China's military is developing what it calls 333 Formation 2.0, a fundamental transformation of the standard infantry squad into a combined human-robot unit.
One is the astonishing growth of artificial intelligence and robotics in military planning. The other is the possibility humans might not even control the decisions.
The structure is 9 human soldiers, paired with 3 robot wolves per squad. This formation extends the squad's combat radius from 500 meters to 1,500 meters and increases firepower by 200%. That is not a marginal improvement. It is a complete redesign of what a small infantry unit can do and how far it can reach. In practice, this means human soldiers direct the overall operation, while robot wolves handle the most dangerous forward roles. Scout units move ahead of the formation, identifying enemy positions and feeding targeting data back to the squad. Strike units carry weapons and execute precision attacks. Supply units follow behind, carrying ammunition and medical equipment so human soldiers do not have to expose themselves to retrieve it. The robots absorb the risk that previously fell on the most exposed members of the squad. This is not a future concept being debated in a think tank. It is an active doctrinal development being tested in live military exercises right now, including the January 2026 drills broadcast on state television. The drone integration running alongside the robot wolves adds another layer. The integrated system combining bomb-dropping drones, smoke-laying drones, and suicide FPV drones creates a coordinated tactical unit where robots on the ground and machines in the air are operating as a single system. Human operators manage the strategy, the machines execute, and the cost structure behind all of it is what makes the scale possible. China's industrial ecosystem has driven production costs for military robot wolves down to thousands of yuan per unit. Comparable systems developed in the United States cost approximately $70,000 each. That cost differential does not just affect how many robots China can field, it affects how many it can afford to lose, replace, and improve through real battlefield data. A military that can produce robot soldiers at a fraction of the cost of its competitors can iterate faster, deploy wider, and absorb losses that would be strategically statistically significant for an adversary. If a robot wolf costs thousands of yuan and an American equivalent costs $70,000, China can field 10 units for every one its competitor deploys. That is not just a cost advantage, it is a strategic multiplier that compounds with every generation of hardware. Set aside the combat league, the factory deployments, and the military exercises for a moment and look at the shipment numbers from 2025. Agibot shipped approximately 5,100 humanoid robot units. Unitree shipped approximately 4,200 units. UB Tech shipped approximately 1,000 units. These are Chinese companies that most people in Western countries have never heard of, shipping more humanoid robots in a single year than the rest of the world's robotics industry combined. China has committed $26 billion in state funding across more than 140 humanoid robotics companies. The embodied intelligence industry is growing at over 50% annually. Market forecasts put the sector at 100 billion yuan by 2030. Tesla has not opened Optimus pre-orders. Figure AI only became revenue generating in December 2024. Boston Dynamics Atlas is being piloted at Hyundai facilities with no confirmed commercial price or public sales date. China is not competing in the same race. It is running a different race entirely, one where the factory, the fighting ring, and the battlefield are all part of the same industrial strategy, and the gap between where China is and where everyone else is continues to widen every month. Engine. AI built a combat robot and put it on sale. UB Tech shipped hundreds of humanoid workers to the largest manufacturers in China. The PLA integrated robot wolves into live military exercises on the first day of 2026. These are not separate stories. They are the same story told from 3 different angles. China is not building robots for one purpose. It is building an ecosystem where the same industrial base that produces factory humanoids produces military systems, where the same engineering talent that designs combat algorithms for Fighting League informs the next generation of autonomous battlefield units, and where the cost of producing all of it is lower than anywhere else on Earth. If the question at the start of this video was whether the next soldier on a battlefield might not be human, the answer coming out of China in 2025 and 2026 is that the transition has already begun. It is happening in factories, in arenas, and in live military exercises. The only question left is how fast it moves from here. China shipped more humanoid robots in 2025 than the rest of the world combined. Factories, fighting rings, and battlefields, and 2026 is only getting started. If you want to see what China's most human-like robots look like right now, that video is up next. It is worth watching.